So Dr. Adrian Baldwin is a senior researcher in the security lab within HP Labs, UK. Over the years, he has worked on and published in a range of security areas, including security analytics and using machine learning for security, modeling systems to understand security trade-offs, automating audits, and securing audit logs. He obtained his PhD in neural networks and natural language understanding from Exeter University. So everyone, let's welcome Adrian to deliver the first talk to get us started in this workshop. So let me stop sharing. Over to you, Adrian.
Okay, I shall try and share. Can you hear me? Yeah.
Yes, we can hear you.
Yes, good. And share. Right, so just moving Zoom bars around. Okay, so I'm Adrian Baldwin. Like the intro said, I'm from HP Labs in the UK, and I'll introduce a bit about myself in a moment. But this is work that's been done with a few others, really, including people in HP Labs, but also our HP NTU lab, where Deelupa, for example, is working, and he's one of the conference organisers as well. So this is kind of a joint effort. And I guess, what's the subject about? So in the enterprise, we deploy systems and operate our solutions. As we do that, we need to understand the risk and the security and compliance risks, really, and mitigate those where possible. And in other words, I guess from a trust perspective, we really need to trust that the solutions aren't going to do people aren't going to do bad things to our business through those solutions, and those solutions can deliver the right service to our customers. So in this talk, I really look at how we understand risks within ML, but taking it very much from an enterprise perspective of how we already understand risks and how that's different from ML. So just a bit about my background. Really, I don't consider myself an ML researcher. I consider myself a cybersecurity researcher, having worked in cybersecurity in HP Labs for 25 plus years. And I guess I've got a background where I've worked in things like malware and attack space, understanding governance and risks, but also things like using ML to look at security, to try and do security detections, looking at things like analytics of events there. My current project is actually looking at social and edge to cloud trust. But I really got interested in the area of, in this kind of mix between security and ML, and the area of secure ML and trustworthy ML, because I many years ago I had a background in ML. I did my PhD looking at, as we called it then, connectionless natural language understanding, and spending a few years looking at acoustic classification using neural networks. But that was a long time ago, really not long after the generalized delta rule paper came out in, I think, 86. So it was somewhat more challenging at the time. So maybe my approach to ML is a little bit antiquated, but like I say, more recently I have been working in ML for security analytics and this kind of area of, well, how do we trust ML systems? So talk-wise, I was going to introduce how I see enterprise and security governance and briefly mention the ML issues there. Talk a bit more about ML attacks and threats, because I think at any time you look at risk and what it means to keep the solutions running in the way you expect, you need to understand, well, what's the underlying threat environment you've got, and then talk about our approach to understanding risks and examples of the type of controls that we think should be put in place there. And hopefully I'll get time to cover some of those examples. So this really, sorry, this slide is really intended to summarize how I see the overall process for enterprise security governance, where we start off at the top with identifying IT risks. We do a more detailed risk assessment where we start to ask, well, which are the likely risks and what's their impact going to be on the solutions we offer or the operation of the enterprise. And doing so, we bring in our kind of situational awareness of that threat environment. And that's obviously a changing environment. We then look at kind of the economics around, well, how much do we want to spend on security? How much do we need to spend? Where do we best invest to mitigate threats? This leads to the development of a kind of controls framework. So I see controls here as a mixture of people, process, and technology controls. So people are the simple ones, maybe. So we can talk about things like training people to understand risks. So one of the standard ones that seems to happen at the moment is the security training that everybody in an enterprise gets, including things like making sure they understand that phishing will happen and that they know how to detect it and react to it. Process controls, I guess there's a whole range of different processes. So typical examples might be, or when we spent a long time looking at audit, a lot of the auditors looked at processes around how you manage users within an enterprise. So making sure users really were who they employees, but more importantly, that the users had the right access to systems, but not the wrong access, and managing all of those processes. But other processes are things like, well, how you respond to incidents and so on. And they're often kind of workflows of things you do when risks, to mitigate risks, stop risks happening. And often they're kind of preventative controls. And then there's a whole set of technology controls that enforce things from the technical level, whether that's the authentication systems on your PCs, or whether that's malware detection systems and so on. There's a whole, and so our response to risks is to have that whole set of controls, whether they're technical, procedural, and people controls. It's not enough to just put controls in place, of course. You need to monitor to see what's happening and monitor that the controls are running as you expect, but also that they're mitigating the risks that you originally identified. And as I say, the risk situation changes, and so you need to keep on reviewing and updating your controls to check that they're really mitigating the real risks that you deal with. And of course, in an enterprise situation, you don't make up all your controls from scratch. What we have is a set of standards, things like ISO 27000, NIST 853, COBIT as an audit standard, which covers a lot of controls. And they identify all the different areas where we worry about security and risk and dig deeper and deeper. Often things like ISO and COBIT talk about principles that you must achieve. NIST tends to be more technical and give you much more guidance on how you achieve those controls, but they give you the overall framings. What we don't have a good system for at the moment, I would argue, is what the controls are for ML systems, because they're different. NIST has started in that area, and I'll come to that in a moment. There's other key enterprise security processes which I think are worth mentioning, but I'm not really covering these. There's kind of threat modeling, the secure software development process. So as we develop a solution, we do a lot of threat modeling to understand the threats in that solution, to mitigate those threats and design better systems. And I mention this here because one of the approaches to having more secure ML, which I think is essential for more trustworthy ML, is around the software development lifecycle and bringing the ML aspects into there. And Microsoft have done a lot of good work here, because I think they really brought together the secure software development lifecycle a good few years ago. And they've kind of continued that, looking at how ML fits into that. and give very good guidance there. The other area I think is really important is instant response. When you get an attack, how do we detect and manage that? And I bring this up because I think it's important to understand, well, actually, we do need to detect attacks as they happen on ML systems, but also have ideas of how to deal with it. And I think at the moment, the attack space is really, really immature in ML systems. So we need to understand how we grow this kind of response framework and how we bring that situational knowledge that this brings back into the overall risk space. So I think this comes to a question, and I started to talk about this a minute or so ago, where is ML different from the approach we have for understanding risk in the enterprise? And to a certain extent, no. I don't think we need to do anything differently fundamentally. This approach of understanding risk, having controls that are in place, modeling the threats, mitigating them, that's all good, a good approach. It's just, well, ML is a different computing paradigm. It is data driven. So we don't have a spec for our models. Instead, we have it derived from the data we have. And that leads to different threats, different processes. So therefore, we need different defenses and different controls that help us think about risk in maybe different ways, but aggregated up into that overall way we think about risk. The other area I think is really challenging from a risk perspective is ML solutions accept a certain amount of risk. You know, no ML model is perfect. They fail in a way that we don't expect software to fail, and that brings an inherent risk that enterprises need to understand and accept as we operate ML models as parts of our solutions. And I think this, as parts of our solutions, is the key thing. The solution is the important thing, not the ML model. It's the service that we offer to customers or what we use to drive the business internally that's a really key thing. And that's the thing that people attack as well. The other point here is actually there's new threats that come along through because of ML, because of the way ML can be attacked. But we shouldn't forget the conventional attacks, because ML solutions sit on conventional IT solutions as well. And with that, I'll talk a little about the attack space. And I guess this is my kind of very brief summary of, we have an ML life cycle where we go through data preparation, model training, we release the model, and we deploy the model. And the attacks can happen at different stages here. But often, actually, a lot of the attacks are maybe at the deployment level. And from an ML perspective, as opposed to the conventional perspective, we often talk about, we see a lot of work having been done on evasion attacks. Basically, there's a whole raft of work where what they do is, for example, in an image classifier, they mutate the image with small amounts of noise so that it changes the ML decision that's coming out, and do so in fairly hard to spot ways. And that can be applied to images where it's normally applied, but we've looked at how that applies to telemetry data, and it can be applied to natural language type of models as well. But that's a whole attack class in its own right. I think there's an important element of that class, which is, instead of adding noise to the actual image as a kind of technical once you've captured the image within the data pipeline piece, there's a series of attacks, and the one I like to refer to is the adversarial patch, where you basically print something out and put it in front of the camera or alongside something, where having that in the image leads to a misclassification. I think that's a really interesting set of attacks, because that's at the kind of physical environment level rather than through the IT system level. At the model training level, we have a series of attacks, poisoning attacks, where people aim to contaminate the data sets basically that models are trained on, and in doing so affect the model as it's pushed out, or add backdoors in there so that they can put particular bits of data in, and that would lead to the bad response. I think I was reading an example where somebody was saying, well, if you said a facial class, no, I can't remember the example now. One example is maybe in traffic signs, you might train the model so if there's a particular sticker on a traffic sign, it would lead to a response. So maybe a go sign is because then classified as a stop sign, which would be a really concerning type of attack. Last set of attacks, and I think I worry about poisoning attacks. I worry less about the evasion attacks, and I'll come to why later. But confidentiality attacks, data theft attacks, again, I find worrying. There's a whole set of attacks where you can steal a model, and what you do is you throw different queries at an API that the model responds to, so different data in, get the results out, and from that you can build up your own model. Now, it's not really theft, I guess, in a way, because you've not got a copy of the model, you've got something approximating to it, so it's not a copyright infringement. If the API is there, you're merely using the API, but it is getting you a copy of the model. And that model also can give you important information about for further attacks, or it can give you the IP that somebody spent a long time working on. There's also model inversion membership attacks, where you can obtain the training data. Keeping an eye on time. As well as understanding the attack space, it's important to understand the attacker. And as a security person, we should always think about the attacker at some point, and first of all, what the attacker's goals are. And I think the next slide talks a little bit more about how attackers work, which I think is important to think. The attacker doesn't want to attack an ML system. They want to make money. They want to get data that they can sell or use in their business, disrupt a system. They have a goal. Attacking the ML is just part of doing that, and they have a whole set of different techniques they can use. When we look at the techniques, we need to think, well, in order to attack that solution, what is it they need to achieve? For example, is it enough to have a bad classification to force something wrong to happen, or do they need a particular output that's required so that they can flip a decision? And that can be a lot harder to achieve than just disrupting the system. Then we need to think, well, what knowledge do they need to do to craft a particular attack? Do they need knowledge of the actual model that you're using, a copy of it? Is it enough to know about some of the parameters in the model, or can they do it from a completely black box perspective? And that I think is key knowledge, because that comes to the attack complexities, which is how much effort if I'm an attacker, do I need to put in to attack a system? If it's a lot of effort, I'm probably not going to go that route. And the thing we do know about attackers is they take the route that they perceive to be easy, but they're very creative as well. Just on the attack space, because I come from a fairly traditional cybersecurity background, one of the really useful tools we have is the MITRE ATT&CK framework, where what we do is say, well, attacks are multi-stage. Very few attacks are a single stage attack. And there's a whole series of tactics that the attacker goes through. Each tactic is there to achieve a particular goal. And so that might be, well, gain initial access to a system. It might be to exfiltrate data from a system later on. And what MITRE really do in the attack framework is they've documented a whole set of techniques that the attacker can use to do that. So initial access, it might be, well, they send you a bad email. or they hack a they get shellcode executing in a web server. So there's lots of different ways to achieve this, and even within each of those techniques, there's lots of different procedures, which is the detail of how those attacks happen. And really, the attack chain is how the attacker achieves their goal. Now, as I say, the attacker's goal is to break a system, make money from it. You get the impact, and we can. So one of the things that some people have started to do, and there is a MITRE work on mapping the attacks that are known about with ML into a separate attack matrix. But I would argue against that, because I would argue actually we need to place the ML attacks within the overall solution space, because it might be that actually conventional attacks are used to manipulate data paths into the model, so we can do evasion attacks and change the data in a way that leads to a bad decision. It might be actually ML is used to avoid detection, because we know a lot of AV systems use ML to detect malware. And it might be actually part of the exfiltration stage to exfiltrate data by stealing the model or something. But I would argue ML attacks are merely other stages in an overall attack chain that an attacker does that helps them achieve a goal. So we should sit within these overall frameworks. And just to say, I talked about techniques as one way of doing it. So you can see evasion, model evasion as a technique, and actually there's all these different evasion mechanisms that people have designed that then become sub-techniques and so on into that. Or sub-techniques or procedures, depending on how far you go down, whether it's white or black box attacks, and then procedures for doing those. And when we look at the attack space, we should realize not all risks are attacks. We have risks just because things go wrong. We make mistakes. And so, for example, the big risk I think that we always have in ML is if our training and test set data are biased, they don't represent the real world that we're going to deploy into. That gives us risks from the solution side in terms of operating solutions, but also if people learn about them, they will take advantage, of different pricing models and so on. People are clever that way. And then there's a whole set of ethical and compliance risks, such as privacy risks, if we've misused people's data, so we didn't get the right consent for data, or if there's ethical issues on the fairness. So if solutions don't work for certain races, for example, they're really huge risks for enterprises, but with cost of brand, but also regulatory fines and so on. So we need to take all of that kind of threat environment and additional risks into account. So how are we approaching risk? First of all, I will say, I think the risk situation in ML is complex. There's a lot of different people and lots of different skills involved in generating ML solutions here. And they, from the data engineers, data scientists, who have knowledge of parts of those processes, along with security experts who actually, most security experts really don't understand ML. They don't have that background. They understand the traditional attack space and the traditional defenses against the attack space. So there's often a kind of disconnect between these worlds. And the people I haven't included in this list of things like the DevOps engineers and the solution engineers who produce the underlying solutions. And we have the business owner. We should never, when we think about risk, we should really always think about the solution and business owner, because they're the ones who understand what risk means. They're the ones who understand, well, if I have somebody break into my system, that will be a cost to my business. That might mean I have a loss that I'm not expecting. Or they might have ideas about how attackers can take advantage of their system and the costs that that it leads to then the impact of risk on the overall business. So they're really key stakeholder there. But I see a real discontinuity of knowledge gaps between all these different groups of people. So what we're trying to do as a team in a project with some of the work we're doing with HB and the NTU lab is look at, can we create tools to help guide people through the risk? Yeah, think about the risk frameworks that we have for the enterprise. How do they differ with ML? What are the taxonomies of risk and the controls that ought to be in place? And use those to drive a risk tool so we can gather the right information. But actually, the point isn't necessarily to gather the information, it's to make people think about the different areas that they need to control things. Have calculation mechanisms where we can start to show, well, actually, you're covered well in these areas, but not well in these areas. And overall, your risk, say, with confidentiality is poor, your integrity of your solution is good. So help people understand the areas they're strong at, the areas they're weak at, so that they can then start to think about how they invest in better controls and improve things. And also think, well, if I have $100 extra spend on security, well, where do I spend it? Help them think about that. But bring in the threat information as well into this, so that if when the threat space changes, because it will change, how we update that knowledge. Part of this then becomes around developing this kind of controls taxonomy. And I'm not going to go through this in detail. We've got a paper covering some of this. But I think what we've done is kind of group this in 4 areas. Data obviously is key for, data security is obviously key for ML solutions. The whole model evaluation and modeling process is another key area to have controls in. And then I see the execution environment as really important as we deploy ML models. And because models are different, because the way we run ML is different, then the controls become different from a standard IT solution. And again, there's a whole set of different security control areas, things that we would typically do in an enterprise to keep security, but are slightly different when we get to ML, such as, well, what does it mean to, say, do forensics on a solution if it's been hacked with a ML model there, as opposed to a traditional system? So there's areas of change there. And what I was going to do in the last few minutes of the talk is quickly walk through some examples of where we see things of importance, and to do so within the context of the overall ML life cycle, from problem definition through to labeling, training models, releasing them, monitoring, and so on. Where my first comment is, well, underlying all of these processes, we have these kind of lighter boxes which represent standard IT solutions. And going back to where I started on the kind of cybersecurity frameworks, something like the NIST framework, we have a lot of mechanisms. We know how to manage IT solutions, so we shouldn't forget that when we do ML solutions. But there's differences as well. And the first area I think is really important is to think about data feeds, because we talked about evasion attacks and changing data, but actually a whole class of those attacks can maybe be closed off if we have trust in the data source. So, for example, if our ML systems are based on having lots of sensors, say in a factory, we have a whole load of sensors out there, and our ML models are helping make decisions about the control lines. If we have good reason to trust the sensors, so good security on the sensors, and authenticity and integrity of the data as it flows into our ML models, somebody doesn't have the ability to do those subtle changes on the telemetry or images as they come in, and they don't have the ability to do those evasion attacks. So if we could do good data security, we can close off a whole load of the attack space. The reason I mentioned things like the adversarial patch earlier is that we do potentially have the ability, an attacker still has the ability to maybe physically tamper with or physically insert things in front of the sensors that can lead to bad decisions. And so things like the evasion attacks are still of concern when you get past those IT parts where we can control the data path and the trustworthiness of those data sources. IoT sensors, cameras, where we can refer back to trusted computing based on those. Labeling processes are key, and because I talked about data poisoning, model poisoning, and I would argue one of the big controls we should think about is actually the access management in the modeling process. So only the subject matter experts who really have the knowledge of what they're labeling are doing that labeling. Otherwise, we'll get mistakes. I'd argue one of the things we do when we release solutions, we do code reviews. We need equivalent data reviews just to sample the data to say, actually, this really isn't a good form. Look for outliers. But when we talk about poisoning, there's a whole set of research looking at poisoning detection and methods to mitigate if poisonings happen. So there's a set of papers that look at kind of pruning deep neural networks, for example, if they've been poisoned, so that it reduces some of the connections and reduces the impact of poisoning, or looking for strange activation patterns which might help detect backdoors in there. So if you've got your general path from data up to the certain sensitive classes that you might have, is there a different path that seems to be in as you feed activations through your network to look at that? So there's different ways to address those issues. Then attack detection more generally, and I talked about evasion attacks, and I think they are important from this notion of, well, actually, sensors, data sources can be attacked. They're not perfect. Often actually, IoT security is challenging, particularly if it's physically distributed. So we may get the evasion attacks logically, or we may get them physically. So we should be aware of that and think about the attack pieces here. So there's a lot of work in, say, data filtering defenses, attack detection. So you have a model alongside your classification model. You might have a model to say, this looks like attack data, or autoencoders to filter data. There's a lot of work and actually a couple of nice toolkits, which I've mentioned here. The ART one that I think comes from IBM, and Microsoft have got this counterfeit tool set which can be used to assess the attackability of a model. So once you've trained a model, is it subject to known evasion attacks? So there's sets of tools that we can put in place and use as we release those models. More robust training techniques that become important, and I think we should think about, as we train models, we should think about, should we use more robust training? Things like defensive distillation. Ensemble mechanisms tend to be more robust anyway, or adversarial training, where you throw adversarial examples in as you train your models. All of these techniques can be used and put in as controls. One of the questions is, well, given the attack space as it is at the moment, how much effort do I put in here? And maybe not a great deal at the moment, because we haven't seen these attacks really in the wild, but they will come. So we need to be prepared, and we need to prepare, if a model's going to be out there for 10 years, say we distribute models into hardware that resides in factories, it doesn't get changed, or we don't expect to update too often. Those models can sit around for many, many years. So we need to be aware of that from the attack perspective. And the last point here was around access detection patterns. If we're talking about model stealing, where somebody comes in, queries an API into a model, we can start to do kind of almost fraud detection. Think strange access patterns are happening, so we can detect that people are maybe attacking the model, trying to steal it, and detect that and close down those attack routes, the IP addresses people are coming in from. The last part quickly I wanted to mention is actually supply chain is really important. It's a big thing in security at the moment, talk about supply chain and trust. If we're pulling out our models from third parties, if we're pulling data sources from third parties, and even if we're pulling models, open source models, say, using them to transfer learning for our solutions, if they've been poisoned, our solution can be poisoned. So when we pull in data, think, how do we trust that third party? That's really an important part of trust. Can we use the mechanisms that I mentioned earlier to assess third-party models and data as they come in? So to summarize, and we'll have a few minutes, maybe 5 minutes for questions then. Enterprises really need to think through risk as they deploy ML models. The controls and mitigations they put in place are different. But ML is an immature world, so this will kind of gradually build up over time, the controls that we put in place. And we're seeing that with the emergent standards. NIST is looking at and starting to put standards around ML security. So that will become a growth area, I think, that will help drive that. But we should remember, attackers are creative and hard to predict. They will come up with intelligent new attacks. We need to be responsive. We need to monitor the attack situation, but also aim for those preventive controls. More robust models, better data pipeline security, so that it becomes harder and harder for them to attack. So I'll open it up to questions for a few minutes. I don't know if questions come over chat or people unmute. That's probably best.
If no one is asking a question, I can ask one. Yeah. So Adrian, thank you very much for the informative talk. So it's a very good starting point for the workshop. During your 25 plus years of experience as a cybersecurity professional, were there any major events that caused you to look at machine learning security in particular? I'm just curious.
I don't think there have been. I don't think there's been ML attacks particularly out there that I've seen. The one thing I would say is a lot of antivirus systems, malware detection systems, use ML, and attackers really try and evade them. So we got a whole load of work looking at, well, how robust are AV systems, because we know attackers try and evade them, and because they use ML systems to try and detect things, I think there's a really interesting arms race there of how clever the attackers have to be. Are they going to use evasion techniques to try and evade AV systems and have this kind of complex feedback loop? So I think that's been one of the really interesting areas. And we have seen a few papers published on modifying code to basically using evasion techniques on malware code, but that was to avoid attribution. At the moment, the AV systems aren't that robust that they need to do anything too clever. They can put in, additional noise, mutate code using standard mechanisms. So we're not there yet, but I think that's one of the areas that really will become interesting.
Right. Thank you very much, Adrian. One more thing, maybe a short answer will be sufficient. Yeah. About you choose confidentiality, integrity, and availability, these concepts to evaluate and quantify the risk.
Yeah.
So these confidential, integrity, and availability relate to the company assets and the things that are related to company. So do you plan to consider other aspects as well? So I feel that confidentiality of some indirectly related assets will also will result in trust issues in the long run.
Yes, and confidential. I mean, they're general terms I guess. So it can be for the company's assets, but it can be for things affected by the solution or things along the way.
Yeah.
And
I guess that's
we
the
talk
main
about,
challenge, right? That's the main
yeah,
challenge, yeah, when you
yes,
compare to
yes. Yeah, and we talk about the
decision
CIA triad because a lot of security people do. There's other versions of it. There's people who talk about 6 different aspects, but it's often these different aspects. And I often think integrity is the really important one, because if the data is not good, you have bad decisions, lead to bad processes, bad decisions, cost. Confidentiality becomes important if you're losing data that's valuable. But often, sensor data may not matter too much. So that's where there's kind of trade-offs between different pieces. And we've done a lot of work on security trade-offs between these different pieces, which are very solution dependent.
Right. Thank you very much, Adrian. So we'll be able to discuss more during panel discussion.
Yep.
Thank you very much.
Okay, thank you very much, Adrian. So like Dileepa said, you will get another chance to talk with Adrian and ask more questions during the panel discussion.